Hello learners, this is Teacher Marichu and welcome to our distance learning using math packs for senior high school students pre-calculus Quarter 1 Week 3A. In this module, we have the objective is for you learners to define an ellipse. For the generalization, I leave it to you to just simply read it for your self-study. Let me go directly to the definition of an ellipse. An ellipse is the set of all points on the plane, the sum of whose distances from two fixed points called the foci is a constant. So F1 with coordinates negative C0 and F2 with coordinates C0 are what we call foci. Or if we are referring only to one, we have focus. This is the focus of an ellipse on the left-hand side of the center, and on the right of the center, we have focus F2. Parts of an ellipse. So we have the center. The standard ellipse is centers at the origin with coordinates 0, 0. Then foci or focus, as I had mentioned earlier. Take note, each focus is C units away from the center. And for any point on the ellipse, the sum of its distances from the foci is 2a. That means, let's have this point P. Any point P on this ellipse. If you connect this point P to focus F2 and connect point P to focus F1, if we sum up the length of F1P plus the length of F2P, it is equal to 2a. That is how it says here. Now for the vertices or vertex for its singular meaning, we have V1 is negative A0 and V sub 2 with coordinates A0. It says here the vertices are points on the ellipse collinear with the center and the foci. That means it is in line, aligned with the center and the foci. Now if y is 0, then x is positive or negative a. Each vertex is a units away from the center. And the line segment V1, V sub 2 is called the major axis. We have the blue line here. This is the major axis, the longer length. Its length is 2a. It divides the ellipse into two equal parts. So you have the description of the ellipse here. Ellipse with horizontal major axis. Now, what are the co-vertices or co-vertex? A co-vertex is the one within or aligned with the minor axis. There are 2 points here, W sub 1 and W sub 2, with coordinates given here. The segment through the center perpendicular to the major axis is the minor axis, the red one in this case. It meets the ellipse at the co-vertices. So meeting the ellipse at its co-vertices. It divides the ellipse also into two equal parts. So we have here the arrow represents this arrow, major axis, that's the blue line. Then we have the red line, it represents the minor axis. Obviously the center is here. And from the center going to V2 or the center going to V1, the measure there is A. And from the center going up to W2 and from the center going down to W1, it's actually length B. Okay. How about the C? Well, from the center going to either of F1, center going to F2, then it is the distance, the distance from F1 to the center, and from the center to F2, or the focus, then it is called C, or the length C. Now, if x is 0, then we have the coordinates of y are positive and negative b. Each co-vertex is b units away from the center. Take note, segment W sub 1, W sub 2 is 2b units long, since a is greater than b. The major axis is longer than the minor axis. That's always the case. Whatever is the longer length in this axis, so we have to consider the longer length in an ellipse is what we call the major axis, and the shorter length within this center, meaning it's collinear with the center and either the co-vertices or the vertices, so it is also a minor axis. So this is an example of ellipse with vertical major axis. So for example 1, I don't have to discuss this, it's very easy. Now let's have exercises 1. We are given the ellipse and we are instructed to name the part of the ellipse represented by the following coordinates, and let's refer to this figure: 0, -5 and 0, 5. Where is that? 0, -5 and 0, 5. Now, those are the co-vertices because those 2 points are collinear with the center, but they form line segment that is considered as a minor axis. So, these are what we call, let's see the solution, it's co-vertices. For number 2, line segment whose endpoints are the co-vertices. So we have minor axis. For number 3, points -12, 0 and 12, 0. So F1 here and F2, so they are what we call foci. For number 4, points -14 and points -14, 0 and 14, 0. These are the vertices. Okay. And number 5, line segment whose endpoints are the vertices. They are what we call the major axis. We move on to another example here. I leave it to you just study it independently. Let's have the exercise. The two numbers here. Let's answer what is asked. What are the coordinates of the center, the foci, the vertices, and so on? So let's have for ellipse A. Let's get familiar with ellipse A. Center, of course, center is at 0, 0. What are the coordinates of the foci? F1 here is -12, 0. F2 is 12, 0. And where are the vertices, or what are the coordinates of the vertices? Let me show you first the solution. Okay, for exercise 2. V1 has coordinates -14, 0, and V2 has coordinates 14, 0. Let's see. It's actually 13, not 14. Okay, stand corrected here. So it's -13, 0 and 13, 0. For the co-vertices, it's up here and down here. So the coordinates 0, -5, and 0, 5. Let's see. Yes. And for number 5 question, find the length of the major axis. In ellipse A, the major axis is the longer, or the major axis is where the vertices collinear with the foci and the center. So from the center going to V2, we have how many units? That's 13 units. And from the center going to the left, it's also 13 units. So sum up 13 plus 13. So the length of the major axis is 26 units. And it is actually on the horizontal axis. So this is considered as the horizontal ellipse. Now for number 6, find the length of the minor axis. Of course, the minor axis is the line segment formed by W sub 1 and W sub 2. The length from 0 down here is 5, and from the center going up is 5 units, so a total of 10 units. So the length of the minor axis is 10 units, and it's the vertical minor axis. For the length of the distance between the two foci, we have from the center going to F1 is 12 units, and from the center going to F2 is another 12 units. So the length between F1 and F2 is 24 units. We're done with letter A, or ellipse A. We move on to ellipse B. Ellipse B is what we call vertical ellipse. So where is the center? The same. We have the center at the origin. Coordinates are 0, 0. Focus or the foci. Foci in here, it has labels as F1 and F2. So what are the coordinates of the center? The foci. Focus F1 as coordinates 0, -3. And focus F2 as coordinates 0, 3. Let's see. There. Then for the vertices. Vertices is where the focus, it's the vertices and the foci and the center are collinear with each other. So take note of these 5 points. There must be a point here. Okay. So for number 4, where are we now? Vertices. Okay. Well, vertices. Vertices, it's from 0, 3, and 0, -. Vertices is 0, 5, and 0, -5. That's for the vertices. How about the co-vertices or co-vertex W sub 1? That is -4, 0. And vertex W sub co-vertex W sub 2 is 4, 0. Then number 5, what's the length of the major axis? From the center going up to vertex V2, 5. Going down to vertex V1, another 5 units. So total of 10 units. Major axis is 10 units. For the minor axis, from the center going to the left to the co-vertex W sub 1, it is 4 units. From the center going to the right to co-vertex W sub 2, another 4 units. So total of 8 units. Now, what's the distance between the foci? Focus F1 and focus F2. Now, from the center going to focus F1, that's 3 units. From the center going up to focus F2, that is another 3 units. So a total of 6 units. I will leave to you for your self-enrichment, the enrichment activity with the following link. It's for your own enrichment also. This is all for now. See you in the next video for Module 3B. Always stay healthy and happy, and always stay safe. God bless.